Right. Good morning to one and all. Now uh, we will discuss Unit 2. Unit 1 completed in the last class. Unit 2, that is Introduction to Solid State Electronic Devices and PN junction diode. We will discuss about today's topic about the introduction of Unit 2, that is a solid state electronic devices. And also one topic in that we will discuss PN junction diode. In the solid state electronic devices, a PN junction diode, BJT, bipolar junction transistor, FET, field effect transistor, or we can call another name, MOSFET, metal oxide semiconductor field effect transistor, diac, triac, and LED. Diac, triac, and LEDs. LED means light emitting diode. Diac and triac, those are the switches. Analog signal conditioning, operational amplifiers, noise, and reduction filtering. See, PN junction diode already you studied in basic electrical and electronics. In the PN means P-type semiconductor and N-type semiconductor, both are sandwiched, and it is forming as a PN junction diode. All of you know that a diode knows, all of you seen the diodes. So diode, for example, if you see in our TV or some other devices, electronic devices, so we can see the diodes. You can see the diodes, transistors, like that. For example, if you open the TV to diode to protect the component, that means from voltage, high voltage. So we are implementing diode. We are installing diode. Same similarly here in this BJT. BJT is also a transistor. All of you know that transistor. Uh, NPN transistor, PNP transistors are there, and MOSFET. It's a very important field effect transistor, metal oxide semiconductor field effect transistor. It's very important. Better you have to put star mark. It's a very compulsory question, 90%. And a diac, triac, and LEDs. LED light emitting diode. All of, these are the diac and triac or the switches. And analog signal conditioning. Here, the analog signal is conditioned. That is, it is making a correct analog signal. And operational amplifiers. Operational amplifiers, the amplifier, it amplifies the signals. It amplifies the signals. Here in this, a dozen in this amplifier, a dozen of resistors and diodes are there in this amplifier. So we can maybe 6 diodes are there. We will discuss how many number of diodes are there, how many number of resistors here in the amplifiers. And then noise reduction filtering. That means noise reduction. That means how to reduce the noise. For example, here in mic I am speaking. For example, unexpectedly we can get to the disturbances. Noise. How can you go for noise reduction with the help of filtering? So here I am speaking through mic, right or wrong. So unnecessarily you can get some disturbances. So how can you reduce this noise? For example, in one big hall or one big stadium, around 5 lakhs members are there, and then the speakers are there. Then, for example, the politicians are speaking. Then some disturbance will occur, like so that there. How can you reduce that noise? Through filtering. There is a noise reduction through filter. That means we can filtering means it eliminates the unwanted sounds. It eliminates, delete the unwanted signals, and thereby we can get the signal output signal is the desired one. That is our required one, comfort. So in the house, of course, in the household appliances also we are having some. We are connecting TVs to the woofer system. That means why here we are arranging a woofer system is to get the output in a good way, to get the output of the signal in a good way, which is better than the previous. That is called. There we can use some amplifiers and filters. For example, if you see in our college seminar hall, there some amplifiers or amplifiers, the filters are there. So it amplifies the output voice, making correct, make, makes correct. There is any disturbances occurs, then automatically with the help of this amplifier, so we can adjust and thereby we can make the signal correct. That means the voice is audible. It's in a good manner. So these are the introduction about the unit 2. Then we'll go for the next. See here, this in this unit 2, it's a very simple topics. Only this see here 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 topics. So if you learn these 9 topics effectively, then you can easily answer the question. You can easily answer. Maybe what I said that that is a FET. It's a very important question. Maybe you can see in 2 sets, and this amplifiers compulsory question maybe in 1 set or 2 sets. Filtering is also. But there is no other alternate here. PN junction diode, BJT FET. Diac is very simple. LEDs. These are the very simple one. Diac and LEDs. And analog signal condition. Operational amplifier will discuss in operation amplifier. Around 5 amplifiers types are there, and the filters is also 4 filters are there: low pass filter, high pass filter, band pass filter, and uh, certain range of filters. The band pass means certain range of filters. So like 4 filters are there. And the next we'll discuss the next one. Now we'll discuss about the PN junction. Uh, PN junction diode in N type material. See here, all of you know that material, N type material, right? And P type material. See here, N type means um, uh, that is electrons, excess electrons. Majority carriers are electrons. Excess electrons move freely in an electron. Whereas in the P type material, the holes migrate as electrons move in an electric. That means holes will migrate into electrons. That means here what you understand in the elements. That means, for example, if you take arsenic like antimony and bismuth, some other, if you take here valence bond and conduction bond, these are all in chemistry, engineering chemistry in intermediate. Here, valence bond and conduction band, there is some gap is there. From the valence band, it jumps into the conduction band, thereby the conduction takes place. That means maybe plus ions or minus. So, see, as if, for example, if you see this N type of material, this is a P type material. In this, 1 minute. See, these are the electrons, right? Here, if you see, these are the electrons. You see, these are the minus of the electrons. Here. You can clearly see these are the minus of the electrons, and see here these are the plus are the holes. You see here this is the holes, right? And these are the electrons. And see in the N-type materials, electrons are the majority category. Means if you see in this block, if you see more number of electrons, and here the see here some of the R holes are there. That the holes is nothing but positive charge. Here the electrons will flow from always, you know that from negative to here the electrons flow, right? In n-type material. Whereas in the case of the p-type material, the majority carriers are holes. The majority carriers are holes. These are the majority carriers. These are the majority carriers are holes or positive charges. That means here the electron flow is in this direction. That means always plus to minus, right? So here the holes are the majority carriers in the p-type material. Is a positive p-type semiconductor. P-type materials. In the n-type material, electrons are move freely, and whereas in the case of the p-type material, holes flow. That means here this is the holes flow, right? Holes flow in the opposite direction of that electrons flow. This is the holes flow in this direction, whereas the electrons flow in this direction. That means here the majority carriers are hole in the p-type semiconductor. These are all you know in the intermediate you studied, right? Then this n-type, for example, this is n-type. In the n-type, for example, if you see the silicon, right? Silicon and this is arsenic, this is silicon, and this is arsenic, right? Arsenic, this is arsenic, this is arsenic, right? In the see here, if you clearly observe the n-type silicon, the arsenic is the donor. Means here the positive charge is there extra one positive extra is there. So that means the arsenic donates to the silicon. So thereby the two becomes neutral. Thereby the two becomes neutral. That means arsenic and silicon both becomes neutral. So this is a neutron silicon atom. So here this silicon needs one ion. So here the arsenic donates to the silicon. So thereby this becomes a neutral, right? This is when this is minus 4 plus 4 minus 4 and minus 5. Here it becomes a neutral 0, and here also it becomes a neutral 0. That means here the arsenic donates one positive ion to the silicon. So silicon that means it receives the electron. That means it is an acceptor. The silicon is the acceptor. No. 1 minute. N-type. That means arsenic is the donor and silicon is the acceptor. That means it receives the charge. See here, this. If you see here, this is my minus 4, 5 minus charge is there, whereas in the silicon 4. And same similarly, go for the next one. And the p-type, if the p-type and the p-type semiconductor. See here, if you see p-type means boron is the acceptor. Here the boron is the acceptor. That means from the silicon, silicon here the silicon is the donor. Here the silicon is the donor, and here the boron is the acceptor. That means here the boron receives. That means here if you see to complete the valence, what I said now that there is a gap between the valence band and the conduction band. From the valence band, it transfers. That means thereby the gap will be decreases once it transfers. Here the charged boron atom is required. Here this here the negative charge. Here in the previous case positive, but now it is negative. And then negative means it accepts the boron. It accepts. That means it needs one. It needs one. The boron needs one. The silicon supplies. Example I am saying. These are all you studied in the chemistry, engineering chemistry. Now it becomes neutral, right? Boron and silicon both becomes neutral. Here the boron, whenever it accepts, receives the ion from the silicon, and automatically both become neutral. Are you understand? Anybody? So actually these are not needed to you. This p-type and just for understanding purposes, I am delivering this one. But this is not there in the syllabus. So remember this point. This p-type and n-type. Now what I discussed, it is not there. Just I am remembering you whatever you studied in the engineering chemistry. And the PN junction diode, if you see in the PN junction diode, the diode is simple. That is, It's very simple p-n junction. That means 1 minute. Sorry for the disturbance. My kid came here. The next p-n junction diode. Here now I will discuss p-type semiconductor. That means so what is the meaning of semiconductors? Partial conduction. Semiconductor means partial conduction. So if you see this forward bias, it can allow current that is from P to N. This is P means positive and N is a negative. This is P is positive and N is a negative. That means positive means a P-type semiconductor. P-N junction diode means the P-type semiconductor is sandwiched with the N-type semiconductor. Here what we discussed in P-type example and N-type example, right? The forward bias allows current, whereas in the reverse bias, no current allowed to flow from N to P. So all of you remember this is the this is here in the forward bias allows current from P to N. That means what is the meaning of P to N? That means from P types to N type. That means the P and N both are sandwiched together and forming PN junction diode. And then this in the forward bias, it allows current. That means uh, current. That means flow of electrons. The majority carriers in the forward bias are electrons. In the case of the reverse bias, so no current. See here, no current from N to P. Reverse bias means reverse direction. It means N to P. Whereas forward bias is P to N, N to P. See here, this is the reverse bias. N, this is a negative N, and this is the P positive. This is N to P. That means no current. That means here the majority carriers are holes. And the breakdown voltage in this breakdown voltage will occurs only in NP voltage only. It means in NP junction only. That is a NP junction of G0. G0 diode will allow the current flow. That means in this direction. That means a constant voltage. Constant voltage. That is called a breakdown voltage. Constant voltage. That means we will discuss later clearly. Whatever in this slide, we will discuss clearly. I will give a brief conclusion to you. The next slide. See here now the PN junction. Now we will discuss clearly about PN junction biasing. That means forward bias. Next we will discuss about the reverse bias. Next we will discuss about that what I said, that Ginner voltage. These three steps. Right. In the previous what we discussed, we will discuss first this one clearly, forward bias, and the next second reverse bias, and next breakdown voltage. These three I will clearly explain clearly one by one, step by step. And PN junction bias. See here, if you see, this is a forward bias. This is a forward bias. 1 minute. I'll take the annotations. Right. See, P-type semiconductor. This is a P-type, and this is N type. Yeah. This is a P and type. The P and N both are sandwiched together. And then here, these are the barrier. This is the, you can also call it as a depletion layer. This here, if you see, if you observe clearly, this is a space. This depletion layer is in between P and N is more. Here, if you see here in this, the electrons flow. Here, the negative is connected to the N-type semiconductor negative terminal, and positive is connected to the P-type semiconductor. See here, positive is connected to the P-type semiconductor, and negative is connected to the negative terminal is connected to the N-type semiconductor. In this, what you have to understand clearly, that means here the positive is there and holes and the negative is there. it will attract this positive holes charge and the negative, that means electrons, will attract towards each other, and thereby the depletion region. See here, the original depletion layer, this is the original depletion layer, this is the original depletion layer, and then it decreases. That means uh, due to the attraction between the positive and the negative charges, thereby the depletion layer decreases. Thereby the electrons will flow. The electrons will flow. So that means here in the majority carriers, or what is the majority carriers? Electrons. And then see here, for example, why here both are attracted towards together. Here the negative terminal is connected to the n type. The n type is negative. If you see, yes, per here, then these are the electrons and these are the negative. Both will repel together. That means this will be some force is added in this direction. Some force added in this direction, right? Some force will be added in this direction. 1 minute, 1 minute. Here I'm searching. Okay, right. Here, see here some force. Here, see some force. See, some force is in this direction. See here, if you observe this negative terminal is connected to the n-type semiconductor. Right here, both are negative. That means the repulsion takes place. Thereby, it moves in this direction. That means from right to left. Why? Because here some attraction is there. Holes are there. Holes are the positive charge. Same similarly, the holes will be attracted towards the negative. Holes will be attracted towards the negative. So thereby the depletion region will decreases when compared to the original. This is the original, and this is after current flow. These are that means the depletion layer decreases. And similarly here, this P type is connected to the positive. That means positive terminal. P type is connected to positive. Both are positive. So here, some of the force is acted towards in this direction. So that means a repulsion. That means the P type and the positive type, both are repulse. So thereby the P type is attracted towards N type, and N type is attracted towards P type. So thereby here the electron will flow from N to P. All of you understand? This is yeah, can understand. The actual this is the process going on. So here PN junction forward bias, the majority carriers are electrons. These electrons flow is, that means uh, the depletion layer decreases. Thereby the flow occurs. The current flow takes place. That means I will tell you next. That means we can regulate the current. Remember this point. Here, what we understand from this output, we can regulate the current. We can regulate the voltage. So depending upon the element here we are using, that is whether p-type semiconductor and n-type semiconductor, the elements are there, there are so many things elements are there. That one already we studied in the periodic table chemistry. So according to that, different elements that valence bond to conduction bond, thereby jumping the gap will be maybe reduce this gap. For some elements the gap may be somewhat decreases, maybe somewhat increases, like that. So thereby what we have to understand, we can regulate the flow of the electrons. That means we can regulate the flow of current, we can regulate the flow of voltage. So the diode is mainly used for the what? To regulate the voltage, to regulate the current. So, for example, in a TV, there are so many components are there. Is there, for example, I want to protect the transformer. So, to protect that component, I have to, before that, I have to install the diodes to protect that transformer. Example, I am saying. That means it regulates the voltage, it regulates the current. Simply, the diode function is it regulate the current. And the next, for example, here some flow of current is more. That means majority carriers are that means minus ion. That means electrons. The next we will go for n type. See here in this, if you see, uh, this okay, right? But here, all of you read this one, right? Already explained by all things. And next we'll go for the next one, reverse bias. Now we'll discuss reverse bias, PN junction reverse bias. So now if you see clearly in this, what here we are arranged here, same similarly, here P and N. Actually, in the previous, if you observe clearly, here actually PN and P type is connected to the positive terminal and N type is connected to the negative terminal. Same similarly, otherwise you can draw, in other words, the figure also. Same similarly, if you place this same as similarly, and then we can change here, this is N and P. That is also we can draw. As you wish, you can draw any methods. But here in the next figure, what this will be changed. I changed here. There is a minus and plus here. So anyway, you can change. That means the minus. See if you see clearly. 1 minute. This is a PN junction and NP junction here. Same PN, but here I am changing the terminals. That means in the previous case, all of it clearly. See clearly. See here. In the previous case, P type is connected to the positive terminal and N type is connected to the negative terminal in the previous case. But now here the changing, the negative terminal is connected to the P type and the positive terminal is connected to the N type. Otherwise, for example, if it is positive means, right, for example, if it is positive, we have to connect to the right type. Don't get confused, right? That means what I am saying that the PN junction, NP junction. If you place here, this is N and this is P, whatever the terminals we have to place as it is in the before. Otherwise, you can change anyway. For example, here I am drawing if it is this is NP. For example, this is NP. And then here you can go for the positive terminal, right? And this is the negative terminal. So to go for this is the negative terminal. Let's see here, this is negative, right? So likewise, you can draw in any way figure. The figures you can draw anyway. This is NP, but here the PN. Here the positive terminal is connected to the negative. In the N-type semiconductor is connected to the positive terminal. So don't get confused. So many members they are doing mistakes here only by connecting to the positive and negative terminal only. Here, if you draw the figure in such a way in the examination, then you can completely it is wrong. So here only in the indication of plus and sign, minus sign, if you made wrong means then automatically total complete thing will be wrong. So while drawing circuit diagrams, we have to be careful where we have to connect the plus and minus. So now see here the P-type semiconductor is connected to the negative and N-type is connected to the positive. This is the original barrier and this is the after reverse bias. This is the depletion. That means the depletion layer, the width is increasing. That means there is no in the previous case the flow of electrons is there, so thereby the width of the barrier will decreases. But here the width of the barrier increases. Why? Because there is no movement of electrons. There is no flow of electrons. See, for example, the P type is connected to the negative means what we have to understand is positive charge, some of thing will be attracted towards because this is a negative and this is a P type force, right? And thereby the flow will be decreases in this direction because of course maybe the positive is attracted towards negative and also this negative is attracted towards positive But here some negative terminal is connected to the p type, right? Are you understanding clearly? Just clear, you have to understand clearly. So there was some of the force will be in this direction, and of course some of the force will be in this direction. Why? Because the positive, that is the charges, will attract it towards the negative. That means only negligible amount of current is passing. Remember this point. In this reverse bias, see here, in this case, here also if you see in this case, n type is negative and it is connected to the positive. Here some of the is attracted towards. So, and some of the things will attract towards, because this negative is connected to the positive and negative is attracted towards the positive. So thereby, and some of the force will goes in this direction. If you go for a depth, then this depletion region increases. Depletion region increases. That means holes, here the holes are the majority carrier. That means the positive charge is the majority carriers. So the current flows, but it is a very negligible amount of current. Negligible, negligible amount of current. This is a negligible amount of current is flowing. So that is in the reverse bias. So that means a negligible amount of current. That means here the current is passing, but very negligible when compared to the forward bias. So here the majority carriers in the N junction is, that is in the reverse bias. In the reverse bias, majority carriers is holes. Whereas in the forward bias, the majority carriers is electrons. That means here also the electrons are flowing in this reverse bias, but it is very negligible compared to that of the forward bias. The next, we'll go for the next one. Can clearly observe and see. If you see clearly this one, you can understand. See here, this is a forward bias. This is completely a forward bias, and this is the reverse bias. The reverse bias. So in the forward bias, if the voltage is increases, automatically the current is increasing. See here, the current is increasing. So of course, the gradually increasing. And in the case of the reverse bias, one particular point of reverse voltage, automatically it will cut and it maintains a constant current. Even though if you increase the uh, here, even though if you increase the voltage, what happens here? Even though if you increase the voltage, so it maintains. That means voltage is means even the current is increasing. Current is increasing, the voltage maintains constant. This breakdown is called, we can call it as a Ginor breakdown. Ginor breakdown. That means one particular voltage, constant voltage, the current is increasing continuously. That is this is completely negative, and this is the forward characteristics, and this is total complete graph, and this is the reverse characteristics of a diode. Here in the forward characteristics, that means forward characteristics means forward bias. The forward bias, when increase the voltage, the current is increasing gradually. Whereas in the case of the reverse bias, it is not happening, because due to the majority carriers or holes, it breaks down. It breaks down for some particular negative voltage. That means here in the reverse bias, that means what we have to understand, it will this diode we can use for to regulate the current or to regulate the voltage. The next, we'll go for the next one. So diode, this is the symbol of the diode, right? This is the symbol of the diode, and this is the top view of the diode. And what we discussed it as two terminals, and this is a turn on at specific voltage, and positive current normally flows from the anode to the all of you know that. P side and cathode, and diodes are basic building of charge collecting of many detectors, right? See here in this from this sentence, what you understand, diodes are useful for protecting circuitry from harmful voltage or current. What I said now. See, the purpose of the diode is to protect the component in a circuit, to protect the component from high voltage or from high current. That means it uh, the component will be in under safe condition by using the diode uh, in the circuitry in front of that particular component. That means anyone, that means the price is very high. For example, the component, the price is very high means we can, that diode is very, it's very minimum price. It's very less price, diode. So to protect from the component which is valuable component, we are arranging before that component in the circuitry, the diodes. We can use maybe dozen transistors also there. Even though same resistor is also the same function. Resistor is also, it opposes the current. That means what is the meaning of it opposes the current? It regulates the current. It regulates the current. It regulates the current. So whatever we need the output voltage for that. For example, take our adapter. You see only 12 volts supply, right? So, but from the household 240 volts is there, but it is reduced. So adapter, we can get from the output of the adapter, we are getting only 12 volts. For example, our charger, it is 12 volts only. If you insert in the plug, only 12 volts only it supplies to the cell. So why here? If you, for example, if the 240 volts, if you directly supply, what happens? The cell phone will get damaged. So to protect that one, we can go for the different methods. The diode is also one of the method. We can to protect any component, price component. So before to protect, so for that we are using diodes in the circuit. Before that we have to arrange. Next, correct. So ends. Any questions? Anybody? Any questions? Any questions? You can ask any questions. So now it is the questions time. You can ask the questions. Anybody? So number here this is not correct. Today at 10:05 only one person came today at 10 o'clock sharply. That means he came at 2 minutes before. Number 38 Raviteja. And all other remaining members they came to the class at 10:05. Some of the members. This is not correct. Sir, I'm waiting for 9:45 onwards in the online. Means 10 minutes before than you. So here this is for you only, but you are not in punctuality means it's very it's not good to you. It is up to the mark. Of course, one person said that sometimes the link is not open, sir. How compulsory it will open, sir? There is some, of course, maybe network problem, right? This not opens means meaning is here when I came to the class means of course even if I am not entered into the class you can enter. It is by pressing the link automatically it will enter to the Zoom. Example I am saying somebody they are understanding in such a way that sir if you come to the class then only it will opens like that. No. So even I will come at correctly 10 minutes or 15 minutes before. No problem. I hope so. Number 31, Keshava, you are having some network problem in your area. Then only the link is not opening. Of course, maybe one or two months. Some persons they are doing, they are coming 10:05 or 10:15 also. I seen some of the members came. This is not good. So now here, just 5 minutes before, I seen it's around 78. Now 4 members came, 81. This is not good. Where it's here, when I was taking attendance, if you are coming means it is be true. Here, these online classes for you only. You have to acquire knowledge. This is not for us. This is not. This is completely for you. So realize yourself. Those who are coming late, have to come to the time on time. Around 113 members are there today. Around 25 members are absent. This is not good. Here in the ECAP, you have to check the attendance, how much you are having. Already, I informed to you that the JNTU Kakinada informed that in this particular semester, online classes only. So according to that only, the attendance is we will evaluate. So if anybody can get around 64.99 also, we can detain. So that means no. Actually, we have to maintain above 75. So those who are getting a scholarship, they will not get the scholarship. Remember this point. If you are having 73 or 74 means you cannot get the scholarship. So as per the rules and regulations, we have to follow. We have to come at 10 o'clock. I will see. So by the end of the day, I am getting the report how many students are attending in the correct time. And how many students are attending in 10:30, 10:40 also I am observing. And how many members they are coming at 10:50. That is now the time is 10:50. So for those members, I will simply put absent. Remember this point. This is not good to you. Of course, almost all some of them they are coming around 50 to 55. They are coming in between 5 minutes gap. But around 30 to 40 members they are coming 10, 20, 10, 30, 10, 20. What I observed. And some of the members they are coming now. Huh? From around now came it's around 7 members came. Hmm? So this is not correct. If you are doing like that means it's not good. Sir, you are a student. You have to maintain in a correct manner. Uh, this is not good. So you have to attend the classes regularly, and then you can observe the attendance in ECAP, right? Observe. So even you have to maintain the attendance 75 above clearly, and also every month same as usually every month first we can post the attendance in your group. Then you can check. Even what I informed to you now, even 64.9 also, if you get, you are be in detained position. Remember this point. And then next, those who are between 60 to 70, those who are eligible for scholarship, they will not get the scholarship. They have to pay a fee. Even 74.99 also, you have to pay the fee. Be alert. అంటే ఇప్పుడు ఈ సిచ్యువేషన్స్ లో ఇన్ ది సిచ్యువేషన్స్ డోంట్ ప్లేస్ ప్రాబ్లమ్స్ ఇన్ ఫ్రంట్ ఆఫ్ యువర్ పేరెంట్స్. అర్థమవుతుందమ్మా నేను చెప్పింది మీకు? ఆర్ యు అండర్స్టాండ్? ఇప్పుడు పాపం ఇప్పుడు పరిస్థితి బాగలేదు. ఇంకా మీ పేరెంట్స్ ఫర్ ఎగ్జాంపుల్ 73 వచ్చింది అనుకో, ఫీజు కట్టాలి. యువర్ పేరెంట్ హ్యాస్ టు పే ద ఫీ. ఎందుకు పాపం వాళ్ళు ఇబ్బంది పెట్టేస్తారు? మీరు కరెక్ట్గా రావాలి కదా టైంకి. బీ పంక్చువాలిటీ ఇన్ ద క్లాస్. Already Jain to Kakinada decided, right? That total complete this semester is online classes only. So all of you check your ECAP. Right, we have to maintain the attendance above 75 percentage. The next, now respond your attendance. Respond attendance. I will call one by one. Number one. Number one, right? 4, 5, 5, 5 చాలా రోజుల నుంచి అబ్సెంట్ అవుతున్నాడు. 7, 7 కూడా. And 8, right? 9, 9, 10, 11, 13, 14, 14, 15, 16, 17, 17, 18, 19, 20, 21, 22, 23, 24, 25. ఎవరు వెళ్ళిపోబోకండి అమ్మా. 25, 26 present, 27, 28, right, 28, right, present, 28 present, 29, 29, 29, okay, 30, 31, 32, 33, 35, 36, 37, 38, 39, 41, 42, 43, 44, 45, 46, 48, 48 option, 49, 50, 52, 54, 55, 56, 60, 61, 63, 63, 64, right, 65, right, 66, 67, 68, 68, 69, 70, 71, 73, 74, 74, 75, 76, 77, 78, 79, 79, 78 present, 78, okay, 68 present, 78 option, 79, 80, 80, 81, right, 83, 84, 85, 88, 89, 90, 91, 92, right. Lateral entry, lateral entry 1, 1, 1 lateral entry 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 12, 13, 14, 15, 15, 16, 17, 17, 18, 19, 18, 18, 18 present kadamma, right, 20, right, 21, 23, 23, 23, 15 present, okay, right, 23, 24, 25, 20, 26, 27, 28, 28, 29%. 30, 30, 30, 31, okay, present. 32, 33, 33, right, present. 30, 32 absent, right? 34, 34, 35, 36, 37, 38, 39, 40, 40, 40, 41, 42, 40, right, 43. Correct. So here the absentees are 5, 7, 10, 14, 15, 25, 27, 29, 48, 63, 69, 75, 79, 80. Lateral tree 1, 2, 23, 25, 26, 30, 32, 34, 35, 39, 40, 41. Number 5, 78 present. 78 I already given. 78, 363 DXC interview. And one person is suffering from COVID. I hope so. Number 35, right? Right. And the next, anybody? 63 and 380 interview, right? 63 and 380. I know. Already they informed. Already they informed. 63 and 380 and 375 also interview, right? And another total 5 members, 3 members, and another 2 members are there. Lateral entries. Who are there? Satish and lateral entry. Satish number 3, Amma. Satish. Lateral entry lo kuda 302. Okay. 302 lateral entry. The next another one more person, Uma Sai, lateral entry. His number is anybody? 338. Okay. 338 present. I already 302 and 303 also. No? 303 is present. And 302. Okay. 302 present. Okay, he is Satish, I hope so. All right, he is attending the 302 and 303 both. Okay. Another Uma Sai number, anybody? Uma Sai. He is also attending Uma Sai lateral. 302, correct. 305 also. No? Okay. Okay, Uma Sai. Okay, thank you all of you. మీరు 314 lateral and okay, 320 present. Okay, present 320. Already you responded 320. 17 batch. Okay, again I'm repeating the absentees. Number 7, 10, 14, 15, 25, 27, 29, 48, 48, 69, 79, lateral entry 1, 23, 25, 26, 30, 34, 39, 40, 41. Okay, thank you all of you. You better in the next class 11:20. I will come at 11:30, right? I will check all the members should be present, correct? Okay, 18 by 32 present.